This presentation is going to show how the quadratic formula was developed, and we'll start with an example from solving for roots of a particular quadratic equation. Here's a quadratic equation that is in the form y equals x squared plus x minus 4. If we calculate a set of coordinates for this, you can see them listed here, going from x equal -3 all the way up to 2. You can see the values for y when we plug them into the quadratic equation. If we plot these on an xy graph, you see the points listed there, and they start to appear to be some sort of curved shape. Plugging in all of the in-between points, we see that it is our familiar parabola shape. So where are the roots of this parabola? Now, roots are the place where a curve crosses the x-axis. In other words, where the function or the y is equal to 0. And we see that those are here. Now, it looks like are approximately somewhere between -2 and -3 for the one on the left, and between 1 and 2 for the one on the right. So we can say that one is -2 point something, and the one on the right is 1 point something, positive value. But what are the exact values? Well, one way to figure out roots is to factor the equation. So how do we do that? Well, we take it and we break it up into two binomials, and since the last term here is -4, we know that it must be a positive times a negative, since that is negative. And so we say, all right, how do we do that? Do we guess factors of 4 that when multiplied together will give us -4, and when added together will give us +1 for the plus x part. Well, we think about those factors, and we come up with nothing. How do we go from here? Well, one way is to use the technique called completing the square, and that's a technique where we make one side of the equation a perfect square and then take the square root of both sides. Let's see how that's done. We start off with this. We subtract -4 from both sides, or add 4 to both sides. Now this is the step of completing the square. We take the x term, the plus x term, we take half of the coefficient, which the coefficient would be 1. We take half of that and square it and add it to the left side. So that's why it's half squared is equal to plus 1/4. 1/2 times 1/2 is 1/4. But what we do to one side of an equation, we have to do to the other side of the equation. So on the right side of the equation, we have to also add 1/4. Now, what that tells us is that on the left side of the equation, that's a perfect square of x plus 1/2 quantity squared. And on the other side, I've shown the 4 as a fraction so that we can get a common denominator of 4. So we take that, and let's go ahead and do the addition there. 16/4 plus 1/4 is equal to 17/4. And now we take the square root of both sides. That leaves x plus 1/2 on the left side, and on the right side we have the square root of 17/4. And of course we have to use plus or minus, because if you square a positive or a negative, we'll get the same number. And we can reduce that a little bit by taking the square root of 4 on the denominator there and giving us 2. So starting with that value, we now can do a couple of things. Well, the first thing we can do is we can subtract 1/2 from both sides, telling us that x is equal to -1/2 plus and minus the square root of 17, all of that over 2. And we can get a common denominator there and say that the answer is -1 plus minus the square root of 17, all of that over 2. So for the first one, we'll say, let's find out what -1 minus the square root of 17 is over 2. And that is approximately equal to -2.5616. And that's shown right there. So there's the answer for that one. And then the exact value for the second one is -1 plus the square root of 17, all of that over 2. And the approximate value of that is positive 1.5616, which matches that number on the right-hand side there. Well, can this process be generalized? And the answer is yes, it can. If we start with a general quadratic equation set equal to 0, ax squared plus bx plus c equals 0, we can apply the completing the square process with the variable coefficients. First, subtract the constant coefficient from both sides. So we have ax squared plus bx equals -c. We then can divide through by the leading coefficient, which is a. So we get a coefficient on the x squared term of 1. That makes it convenient. So we get x squared plus b over ax equals minus c over a. Next step is we use that completing the square step by taking half of the x term, or the x term coefficient, and squaring it, and then adding that to both sides. So half of b over a is b over 2a. We square that and add it to both sides. Then we can expand that and say that b over 2a quantity squared is b squared over 4a squared. Then on the right side, the minus c over a, we need to get a common common denominator, and we would multiply the top and the bottom of that negative c over a by 4a in order to get a common denominator. So we get on the right side negative 4ac over 4a squared plus b squared over 4a squared. So we can now add those two fractions on the right side so that it looks like this. Negative 4ac plus b squared, all of that over 4a squared. And also on the right side, on the left side, we've shown that that whole trinomial there is really x plus b over 2a quantity squared. That's our reward for doing the completion of the square. Now, one other step that I'm going to do here is I'm going to put the b squared term first in the fraction on the right side, so that it reads b squared minus 4ac all over 4a squared. At this point, some of you may be seeing something familiar. Next, we take the square root of both sides. On the left side, we'll get x plus b over 2a, and on the right side, we get plus or minus the square root of b squared minus 4ac all over 4a squared. And we'll go ahead and take the square root of the denominator so that it becomes on the right side plus or minus the square root of b squared minus 4ac all over 2a. Next, we subtract from the left side the b over 2a, leaving us with negative b over 2a plus or minus the square root of b squared minus 4ac all over 2a. And since we have a common denominator there, we can combine these two fractions to become the very famous quadratic formula. X equals negative b plus minus the square root of b squared minus 4ac all over 2a. Thanks for listening.